Bismillahirrahmanirrahim. Okay, let's start with our chapter 1 for Biomedical Engineering and Application. Code BEU41503. It's introduction lecture. Right, as everyone already know, what is biomedical engineering? Basically, the definition sounds like it's a combination between two different fields, which can be medicine and also biology. But the important thing is that we combine these two, medicine, biology, and also along with engineering. For example, we use the principles of engineering to do some sort of design concept studies or instrumentation system that can be used in for healthcare purposes. Right? This field seeks to close the gap between engineering and medicine, combining the design problem solving. So as before, people from biomedical engineering, they used to do the work by themselves, and engineering people, they do the work by themselves. So it is like a very what we call close group. But nowadays we keep on hearing about multidisciplinary research, multidiscipline, combined of a discipline is called multidiscipline. So this is where the biomedical knowledge is combined with the engineering field, right? Then by combining this, you can come up with a design which can solve a particular problem based on the engineering skills and also the knowledge acquired from medical and biological sciences. For example, like in this photo, so basically you need certain knowledge on the materials of this prosthesis, right? Prosthesis of these materials, and then how this material is made. So you need a material engineer in this design. After that, you also need a person with a physiology background. So that's where the medical or biomedical person will come in. And then by also combining this, then you will have what we call studies on movement, limb movements, gait analysis, and then also manufacturing person, where they will do the design, the drawings, the machining of the system. Right? So good thing about the student who's taking this subject is that you guys are actually what we call a person who has multidisciplinary skills compared to if you have just general electronic engineering degree. Now you are actually having an extra knowledge on biomedical. For example, if you go for an interview, right? And then the job is actually to do something with the hospital equipments and system or clinical job. So if 6 students is graduates is present, and 5 of them are mainly in electronic engineering, but you will present there as well. But you do have not just electronic system or electronic engineering knowledge, but you also have biomedical knowledge. For example, like when you graduate from this course, you also have biomedical engineering, biomedical knowledge. So you will have an extra point that you can claim from the interview, so that you are the one who been hired in this interview, if you understand what I mean. So that no worries, because you guys are the one who will be selected, because you have the extra knowledge on physiology, on biology, on medical, on biotechnology. So we try our best to produce you with a certain multidisciplinary knowledge. Right, moving on. So if people ask you what are the breakdowns or the specialty areas. What are the areas that is available? So for example, now sometimes people call it medical electronic engineering, or medical engineering, or biomedical engineering, right? Basically what is to do with medical as the field combined with engineering, combination of engineering, right? And then when you combine this, so these are few areas that was selected in this subject, few areas selected, so that we expose you guys into this field. For example, let's say if you complete this degree, first degree in UTHM, and suddenly you didn't go for work, but you're thinking of pursuing masters, you can do masters in all these areas, what we call biomechanics, rehabilitation engineering, biotechnology, tissue engineering, biomechanics, biomaterials, clinical engineering, bioinstrumentation. These are the areas that are available. So if you, let's say if you're not further studying, you can also explore the jobs in this particular area, because we have provided you with the knowledge that you will be able to join this this kind of job. So we will also look at the definition of few of these the areas that mentioned here, so that we have certain ideas on what is actually those areas which is available. So what's this figure is actually? So the robot hand, this is also belongs to the medicals and robotics. So what's in the heart? This is artificial heart, but this is just a figure. So we know already that there are artificial heart designs nowadays, and it has been used in human as well previously, and even nowadays it's been used. Okay. Next, why biomedical engineering? So that's a good question. There are many health issues in the world that are unsolved. For example, look at this guy. Okay, look at this person, right? He's actually been amputated, right? His hand is no longer a complete hand, so he's potentially he's involved in an accident or whatever his condition, right? But do you think that he is still able to what we call undergo his daily routine and activity? For example, yalah, kalau orang dah putus tangan dia kan, tapi macam mana kita sebagai biomedical engineer boleh membantu orang ni supaya dia menjalani kehidupan dia macam orang biasa? So tangan dah putus, tapi kita masih boleh membantu orang ni supaya dia boleh contoh minum air, pegang botol, boleh minum air, boleh suap air sendiri, boleh suap makanan sendiri. Okay, so macam mana? This is the design. So di depan mata kita dah ada. So this is the design, though it's basically known as artificial hand, the hand which can grip, can carries the bottles, and then can direct to the person, so that he or she can drink water, can take food, and do turn on and off switch, and so on. So many things, right? So, and then the second is the cost of healthcare is growing rapidly, which is difficult to control. Yes, of course, there are few fields that in the world that has no what we call not so there's no limit actually. So it's keep on growing. Other field, sometimes you will reach to the saturation point. They mean that's it. After that, there's no more. But three things: education, pendidikan, warfare, peperangan, teknologi military, kan? Teknologi military, lepas tu, dan last but not least, medical, healthcare. Alright? So this field is very interesting field, very exciting field, and a field that will have so much of development. Dia selalunya akan ada improvement. Contoh, banyak sistem-sistem yang develop dalam medical system ni masih lagi berwayar, kata. Ada wire-wire. This is based on the wiring and so on. But following the technology nowadays, what is happening is that so many equipment has been transformed into wireless system, so that the system has what we call easy mobility, that you can carry the system to anywhere, to any part of your daily work or routine, so you can carry it with you. Contoh dulu orang design tulang palsu, kata artificial bone, artificial limbs and so on. Benda yang masuk dalam tubuh badan ni, dia ada tempoh dia. So dulu let's say this artificial bone ni, tulang palsu ni, ataupun yang kita gantikan dalam tubuh badan manusia ni, mula-mula pada awal-awal dulu dia ada masalah, isu dia berkarat dalam tubuh badan. Jadi kita kena replace. Jadinya apabila teknologi material makin baik, jadi kita dapat buat satu design medical system. It is very what we call you can be used for long term duration. That mean bukan 5 tahun lagi, 10 tahun, 15 tahun, ataupun permanently it stays there. Dia takkan berkarat dan dia compatible sesuai dengan tubuh badan. Jadi ini adalah advancement yang berlaku dalam biomedical engineering. So what we think is that engineers can combine the skill to solve this problem. Banyak permasalahan yang berlaku, tapi engineer ni dia boleh membantu sebenarnya. Okay, next. First of all, we look at this what we call biomechanics. Alright, biomechanics, the definition is the study of how the system, structures of biological organism, from the smallest plant to the largest animals, react to various forces and external stimuli. In humans, biomechanics refer to the study of how skeleton, musculature system work under different condition. Contoh apa? Orang berjalan kan, gait analysis, berjalan, orang berjalan, tubuh badan kita, musculature system dah tahu kan, kita dah belajar skeletal system, musculature system, skeletal yang ada muscle connection, so macam mana pergerakan dia. Okay. So people will try to study about the physical functionality. Okay, orang berjalan macam mana, contoh macam ni kan, dia tunjuk dalam gambar ni. So ada measurement, dia punya perkiraan bending, strain, stress, dan movement, momentum dia. So kalau kita boleh baca parameters ni, we can potentially come up with the simulation, so that to show how the gait analysis is been performed. Jadi kalau kata kita nak design physical organs, physical organs, contoh macam kaki palsu, tangan palsu, jadi kita perlu faham the mechanical function of the organs. Which one? Kalau kaki lah, macam mana dia punya mechanics dia. Contoh daripada lutut, bila kita duduk, kita bangun, berapa pressure pada lutut kan, berapakah pressure pada buku lali apabila kita berlari, pressure yang orang kata berlaku pada hujung ibu jari kaki. Okay, so you can actually calculate this. Ini semua belongs to biomechanics. Maknanya bila orang lari, bila orang berjalan ataupun bila jogging. Okay, so the pressure measurement, the speed measurement, orang lari kan, berapa kelajuan dia. So kita boleh calculate dengan biomechanics properties, right? And then if you want to develop artificial organ, sama juga lah macam prosthesis tadi, kaki palsu. Pernah tengok kan orang yang disable, maknanya dua-dua kaki tak ada tapi masih bertanding dalam acara lumba lari. Jadi macam mana dia design? Kalau kita tengok kaki tu nipis je kan, dia punya kegunaan dia tu very small material, tapi dia boleh menampung berat tubuh badan orang 50 hingga 60 kilogram dan boleh lari kan, dia boleh gunakan untuk berlari. So tu adalah salah satu contoh design dalam biomechanics. And then physical support, contoh digunakan stretcher, tongkat yang tongkat 4 kaki ataupun tongkat yang 2 kaki, 3 kaki, tu pun termasuk dalam design biomechanics. Next important one application yang orang kata is really what we call interesting is called rehabilitation engineering, right? So rehabilitation engineers create methods and technologies to help patients regain cognitive and motor function. Much of the work in this area focus on neurological condition, physical function. Solutions rely heavily on neural, biomechanical and biorobotic engineers. Jadi kalau kita tengok orang ni kan, dia sebenarnya ada support mechanism pada kaki dia, kaki sebelah kanan, kiri. So dia ada support tongkat macam ni kan. Kemungkinan orang ni dia tak boleh berjalan, tapi digunakan alat-alat yang boleh membantu. Itu dipanggil rehab. You try to help a person to regain their health function ataupun bodily function. Sebagai engineer kita boleh membantu orang. Jadi design yang kita buat bolehlah kita orang kata kita bantu supaya design yang kita buat tu dapat membantu pesakit ataupun patient yang gunakan untuk dapat berfungsi dalam society macam biasa. Contoh saya pernah bagi idea macam mana kalau satu orang ni dia kena stroke, kata he's a stroke patient, cuma kaki dia sebelah je yang kena stroke, tapi stroke pun bukan 100%, tapi dia masih lagi boleh rasa, boleh berjalan. Jadi orang ni dia perlukan satu cara macam mana dia nak buat training supaya kaki dia tu boleh regain function. So apa boleh buat? Pernah tengok tak orang buat macam dua rail besi yang orang pegang berjalan daripada depan sampai ke belakang, lepas tu patah balik. Tu adalah salah satu contoh alat yang mudah yang rehabilitation engineers buat ni. Jadi selain daripada tu, lagi advance ada prosthetic, orthotics application, assistive device. Dan nama pun assistive device, maksud dia apa? Assistive, we try to assist people, person with visual impairments. Dia ni mata tak nampak kata. Apa ni visual impairments ni, mata tak apa nampak. Jadi apa assistive dia pakai spek kata. Spek, ada kantar untuk rabun jauh, rabun dekat. Okay, assistive device for person with auditory impairments. Ini orang yang tak boleh dengar. Dia pernah dengar orang pakai tu kan, hearing aids. Hearing aids ada tak? Dia pakai kat belakang telinga kan. Sekarang ni hearing aids ni dah makin kecil. Dulu besar, orang malu nak pakai. Tapi nowadays the hearing aids is getting smaller and smaller. It's very small now. Jadi orang pakai pun orang tak perasan dia sebenarnya pakai hearing aids. Dengan hearing aids tu dia boleh dengar. Sebelum ni kalau dia kata dia tak apa dengar, orang cakap pun nak kena menjerit kat dia. Sekarang dia boleh dengar dengan clear. And then people also have developed this assistive device for tactile impairments, alternative and augmentative communication devices, dan manipulation and mobility aids. So banyaklah dalam rehabilitation ni, banyak benda yang biomedical engineers ni dia boleh membantu. Okay. So still dalam rehab ni, jadi ini adalah apa orang kata, bahagian-bahagian tubuh badan manusia yang memang dah ada sekarang ni pun dah ada dah. Orang kata apa, parts yang contribute kepada rehabilitation. Contoh pada kepala dia, shoulder, thoracic spine, lumbar spine, pelvis, elbow, wrist, hand, knee, tibia, ankle, foot. Semua bahagian-bahagian ni dah ada dah alat sekarang ni dalam rehabilitation. So contoh apa, dia kata walking devices, motion devices, vein devices support, kan, sleep devices, exercise devices, general surgery devices. Ini semua yang termasuk dalam kategori rehabilitation. Okay, so human, kita fokus pada human. Lepas tu kita cuba sediakan assistive technology yang boleh membantu untuk menjalankan aktiviti human ni, macam sedia kala kalau dia terlibat dengan kemalangan dan sebagainya, lost on the bodily function. So lost on the bodily function, and then we can try to help them to gain their function back by assistive technology, which also falls under the category of rehabilitation engineering. Okay, next is biotechnology. Biotechnology ni saya rasa semua orang faham. Ialah kat mana-mana pun kita dengar sekarang ni. Contoh apa, cara-cara kita sediakan biomolecular processes, cells, to develop technologies, products that can help improve our lives and the health of our planet. Contoh apa, bila ada sesuatu breach on the viruses, bacteria and so on, jadi mulalah orang-orang bioteknologi ni dia akan buat kajian-kajian, penemuan saintifik untuk vaksin atau apa-apa saja perubatan supaya dapat membantu mengatasi masalah biological hazard ni, kan, maknanya benda yang berbahaya dari segi biologi ni. Modern biotechnology provides breakthrough products and technologies to combat debilitating and rare diseases, reduce of environmental footprint, feed the hungry, use less, cleaner energy, safer, cleaner, more efficient industrial manufacturing process. Jadi orang banyak bergerak kepada semua perkara-perkara bio-organic, biomaterial, bio, kan. Semua fall under category of biotechnology. So contoh dia, orang fikirkan macam mana cara apa orang kata, kajian-kajian mengenai plant, pokok, padi dan sebagainya, kan. Jadi kita boleh menuai padi dulu setahun sekali, sekarang 2 kali, 3 kali, kan. Jadi macam mana proses tu? Dia sebenarnya melalui bioteknologi lah. Understanding the biological properties behind a certain samples ataupun plant, so that we can manipulate, kita boleh orang kata apa, modify the biological function so that it will facilitate the human being. Alright? Right, ni adalah specific application yang disebutkan: heal the world, fuel the world and feed the world. Biotechnology ni dia boleh heal, katanya boleh heal, boleh fuel, boleh feed the world. Apa dia contohnya? Reduce rate of infectious diseases. Jadi kita boleh, manusia ni dia pandai, kan, dia kaji-kaji cipta vaksin yang macam-macam, kata vaksin yang untuk selamatkan diri daripada macam-macam mikroorganism, bakteria, virus dan sebagainya. change the odd, serious, life-threatening condition of affecting millions around the world. Yalah, bila vaksin dah ada, semua manusia sejagat akan menggunakan. Then minimize health risk, side effect, okay, creating more precise tools for disease detection. Okay, sekarang ni orang pergi ke arah detection machine, right? Contoh dulu, lab proses ni lama. Kalau tak kena gaya, kadang-kadang boleh jadi seminggu, 3 hari, 4 hari. Contoh macam sekarang ni pun, kalau sampling bila dah banyak sangat kes COVID, result nak keluar pun ambil masa, sebab proses detection tu lama. Dan orang tak faham, orang ingat ambil sampel hari ni dapat result hari ni. Bukan. Dia ambil sampel, dia akan makan masa sebab akan proses di lab tu kan. Jadi macam mana kita nak cari kaedah yang kita test sekarang, kita boleh dapat result sekarang. Contoh, kita ambil sampel untuk COVID sekarang, pagi ni, petang dah boleh dapat result. Ada tak cara? Itu heal the world lah. Maknanya the biomedical engineering field will come together with biotech so that we can design, develop a lab-based system which are able to detect diseases quickly, to creating more precise tools, combating serious illness. Penyakit-penyakit ni kita, apa orang kata, biotech ni dia akan keep on producing drugs and things, vaccine and so on, so that they can fight the illness, infectious disease and so on. Fuel the world, chemicals manufacturing process, improving manufacturing process, reduce use of reliance on petrochemicals, and use biofuel. Kan kita tengok orang banyak bincang pasal biofuel untuk nak to cut greenhouse gas emission. Sekarang dunia makin panas, orang pakai aircon makin banyak, lagi panas lagi banyak orang pasang aircon, lagi banyak orang pasang aircon, lagi makin panas. Jadi type of gas being used in the air conditioning system also has been changed. Kalau dulu pakai yang version yang tak green friendly, sekarang dah ada yang green friendly. Okay, tapping into full potential of traditional biomass waste product. Jadi dia fikir long term, macam mana kita nak generate what we call energy, gunakan solar and so on. And then when it comes to feed the world, generate higher crop yields with fewer inputs. Ni lowering volumes of agricultural chemicals required. Ni orang nak guna racun-racun kan, use biocrop that need fewer application of pesticide. Sekarang kita tengok sayur yang kita beli pun banyak dia orang gunakan racun kan. Jadi sayur yang mana yang orang prefer? Orang prefer yang kalau boleh sebaik-baiknya tak gunakan racun. Tapi nampaknya macam susah kan. Jadi macam mana kita melalui bioteknologi ni kita boleh come out with the orang kata compound yang orang kata organic yang materials ataupun chemicals yang tidak membahayakan macam racun, kata contoh. Develop crops with enhanced nutrition profiles, produce foods free of allergens and toxins such as mycotoxin. Jadi macam saya kata tadi, padi kita guna, kita cuba tuai padi bukan sekali, 2-3 kali dah boleh dah sekarang. Kita come out with the baka-baka tumbuhan atau pokok-pokok yang cepat, yang membesar. Jadi itu dipanggil feed the world. Cuba gunakan organic system. Right? So this one is more interesting, tissue engineering. Tissue engineering, apa yang kita nampak dalam gambar ni, dia buat telinga palsu tadi, organic ni, telinga palsu ni. Dia cuba buatkan kat lab ni, dia orang dah boleh grow. Kalau kita pernah tengok, cuba search dalam internet, ada satu studies yang dia orang cuba grow telinga ni di belakang seekor tikus, dia kata. Dia nak tengok macam mana development of that tissue. So it's evolved from the field of biomaterial. Dia gabungan lah, gabungan biomaterial development refers to the practice of combining scaffolds, cells, combination. Maknanya material ada, scaffold ni apa, macam macam tubuh badan kita, skeleton kan, ada skeleton, tulang-tulang tu, itu scaffold lah. Kalau contoh bila kita buat tissue replacement, kita akan tampalkan tempat tu dengan scaffold. Scaffold ni benda-benda yang macam halus, contoh apa, tisu-tisu halus yang akan sel akan melekat pada scaffold tu, dah akan tutup area yang terbabit. Okay, biological active molecules into functional tissue. Goal of tissue engineering is to assemble functional construct that restore. Ni dia punya aim dia. Dia nak restore balik, maintain or improve damaged tissue as a whole or whole organ. Maknanya bila berlaku kehilangan sesuatu bahagian, mungkin disebabkan kebakaran dan sebagainya, macam mana dia nak improve balik tempat tu? Maknanya restore balik, ataupun maintain, ataupun improve the damage part. Kan ni kan orang lebih minat pada cosmetic surgeries, pergi pada cosmetic surgeries yang tidak meninggalkan orang kata apa, kesan-kesan, tak ada marks, orang kata tak nampak, baru buat pembedahan tapi tak nampak kesan pembedahan tu. Currently, tissue engineering plays a relatively small role in patient treatment. Supplemental bladders, small artery, skin, graft, cartilage, even full trachea been implanted in patient, but procedures are still experimental and very costly. Right? Ini adalah contoh dia lah, kan? Contoh full grown bladder implantation. Ni dia orang cuba grow sendiri di luar tubuh badan, bladder podi kencing. Small arteries implantation, maknanya ada berlaku fracture ataupun pecah arteries kan, maknanya explode lah, maknanya putus arteries yang boleh implant balik sekarang ni, dah ada material. Skin graft, skin graft ni yang dia dah tampal ni, graft lah tu. Sebelum ni kalau kata dia luka hilang bahagian ni, dia boleh tampal balik satu graft ni, jadi dia akan mula orang kata apa, lagi cepat proses penyembuhan tu. Dan cartilage ni benda yang melekat pada tulang, yang join, sambung tulang pada tulang kan. Dia macam benda tisu yang bukan lembut sangat lah, keras kan, cartilage. And then full trachea implantation, ini maknanya pembedahan melibatkan trachea. Okay, these are all the interesting application. Ini semua adalah part of application yang orang kata dah ada lah. Sebenarnya ada banyak lagi application. Kalau rajin check dalam online, internet, cuba tengok tissue engineering, apa benda lagi. Sebenarnya daripada hujung rambut sampailah ke hujung kuku kaki ni, semua dah ada dah tissue engineering ni. Saintis ni duk buat. Mereka cuba nak buat advancement dari segi tadilah macam function tadi. What they trying to do is they want to restore, maintain or improve. Restore ni kembalikan, maintain apa yang dah ada sedia ada, dia cuba retain lah, banyak tu je. Ataupun improve, mana-mana yang rosak tu dia nak cuba improve. Okay, right. I think since the concentration bila dengar video ni tak boleh nak lama-lama sangat, so 30 minit ni cukup lah. Saya akan sambung lagi, InsyaAllah I will continue the lecture. So we will start with the biomaterial after this, InsyaAllah. So that's all for today. I will continue in the next lesson. Wassalamualaikum warahmatullahi wabarakatuh.